In this video, we're going to talk about the Apex pre-calculus exercises from section 1.1, real numbers. It starts off with some true-false questions. You'll see that in all of the Apex pre-calculus and calculus textbooks that we're going to look at. In your own words, what does it mean the multiplication division are on the same level? Just a conceptual question here. So we're talking about order of operations here. Parentheses, exponents, multiplication, division are on the same level. Addition and subtraction are on the same level because division is a special kind of multiplication where A divided by B means A times the reciprocal of B, or A times 1 over B. Then we're going to do them at the same time, left to right. That's also why addition and subtraction are on the same level, because A minus B is A plus a negative B. So really subtraction is a special kind of addition and division is a special kind of multiplication. So they happen at the same time, left to right, because they're just as powerful as one another. Where exponents are more powerful, also roots go here. Exponents and roots, exponents and roots go there. They're more powerful than either multiplication or division. And then our parentheses are grouping symbols. So things that are like that are going to take the most precedence, and you go from the inside out. And then within the grouping symbol, you follow this order of operations as well. So that's what we're talking about when we say that they're on the same level. An expression with both addition and multiplication, which operation do you complete first? We're always going for the more powerful operation first. Multiplication is more powerful than addition because it has addition hidden inside of it. We've got to do the multiplication first when we see both multiplication and addition, unless there's a set of parentheses that tells us to do the addition first. Okay. In your own words, what does it mean? Implied parentheses. Okay. And I'm going to have to give some examples here. So whenever we have a good example of this is a fraction, where we have something like 3 minus 4 over 3 squared minus 2 times 3, something like that. Okay, I can't do this division here until I have a numerator and a denominator to divide or to simplify. So there's implied parentheses around the numerator and around the denominator so that we are going to get a numerator to denominator. Another example would be if I give you an expression inside of a square root sign that this is, say, plus 15. Okay, so something like that, I'm going to have to simplify this inside before I try and take the square root. That square root's not going to come out evenly, but that's okay. I didn't mean for it to come out evenly. This is gonna, that fraction would reduce. Let's see. So there's not parentheses there. There's going to be parentheses implied though. Same thing if I have a base here, and this is, say, 3 squared minus 7. That's all small like that in the exponent spot. you know that there's an implied parentheses here in the exponent that I need to simplify that exponent before I do the power, that -7 is not, it's not, right? You know that because we didn't write the 7 big, it's implied there. So there's several different ways we can have implied parentheses. But you need to know when they're implied so that you can write them in your calculator, because your calculator's not smart enough for that. True or false, an expression with only addition or subtraction, with a expression with only addition, subtraction remaining, you must complete all the addition before starting the subtraction. False. They happen at the same time, left to right, because they're on this, they have the same level of precedence. It doesn't matter though if you want to group all the positive things together and all the negative things together, keeping the signs with them. You can do that, but you don't have to do that. The expression -2 squared, it's only the 2 that is squared, not the -2 that's true. If we wanted to have -2 times -2, we would have to write -2 squared. If we write -2 squared, we mean the opposite of 2 times 2. So this is a -4, this is a +4. All right. Now we're going to work through some problems here. Number 6 asks us to simplify. We're going to see the word simplify when we are not dealing with an equation. We deal with equations later in this book. We're going to start with the parentheses. 11 minus 5 is 6. Now we have exponents to deal with before we deal with multiplication or division. 2 to the 3rd is 8. Now we're going to do this multiplication before that division because it comes to the left. Now we're going to divide. We're dividing unlike signs. And we get an answer of 4. Number 7 says 3/5 plus 2/3 divided by 5/6. So the first thing I'm going to take care of is that division because it comes before addition. Leave the first fraction alone, multiply by the reciprocal here. 3 goes into 6 2 times. 3/5 plus 2 times 2 is 4. 1 times 5 is 5. We have a common denominator. So we're going to add the numerators. That's 7 over 5. There's no need to change that into a mixed number, but if you wanted to, it's 1 2/5. Number 8 says 2/3 squared minus 1/6. That's going to be 4/9 minus 1/6. So we have 2 over 2, and we have 3 over 3. That's going to give us a common denominator of 18. That's 8 minus 3 over 18 is 5 over 18. Number 9 asks us 13 plus 7 in parentheses divided by 4 minus 3 squared. So this is 20 divided by 4 minus 3 squared. 20 divided by 4 minus 9. Division before subtraction. 5 minus 9 is a -4. Number 10 asks us what 5 minus 1/2 to the 3rd power is. It's going to be 10 halves minus 1/2 to the 3rd is 9 halves to the 3rd. When I raise a fraction to a power, that's the power goes on the numerator and the denominator. So this is 9 over 8. I'm just going to leave that as an improper fraction. I'll change it for you. That's going to be 91 and an 8. Number 11 is 2. It's -2 divided by 1/2. So 2 times -2 happens first because it's to the left. That's a -4 divided by 1/2. It's going to be a -4 times 2 over 1 is 2. So that's a -8. Number 12 says 2 minus 4, 3 minus 5 over 6 minus 7 plus 3 minus the square root of 25 minus 9. Here's some of those implied parentheses that we're going to have to deal with the numerator and denominator before we can do the division in the problem. But we're going to also have implied parentheses inside that square root sign. So let's deal with the innermost set of parentheses first, which is there. This is also an inner set of parentheses here. All right, let's take care of this root. Now let's take care of this multiplication. Now let's take care of our addition and subtraction. Now let's take care of this division that's left here. And there we go. Thirteen says 2 squared plus 3 squared plus 5 is my numerator of my square root. My denominator of my square root is 2 minus the quantity -1 to the third. The -2 is still, the subtraction of 2 is still under the square root sign. And there's a +6 on the outside of the square root sign. So this is all under the square root sign. I have square root of 4 plus 9 plus 5 over 2 minus a -1 minus 2 plus 6 on the outside. Two plus 1, that's multiplication, so I'm doing that first. So we have 3, 13, and 5 makes 18. This is 6 minus 2. That's an implied set of parentheses there. So that is square root of 4. That's 2 plus 6. It's going to be 8. Four minus 1 times -2 for 1/2 plus 1 minus 2. And I have 4 plus 2 over 1/2 plus 1 minus 2. This is going to be 6 over 3/2. So we're going to have 12 over 3 when I multiply by the reciprocal there. It's going to be 4 minus 2. Don't need the fractions anymore. And that's 2. Negative 4 squared plus 5 squared minus 2 times 3 plus 1. Okay, remember exponents before multiplication. 16, 25. Now we get our multiplication is there. Now we're going to do our addition and subtraction at the same time from left to right. 9 minus 6 plus 1, 3 plus 1 is 4. It says evaluate the described mathematical statement, determine how the described changes affect other variables in the statement as appropriate. The runner leaves her home and runs straight for 30 minutes at a pace of 1 mile every 10 minutes. So distance is equal to rate times time. That's the equation here. So she runs at a rate of 1 mile for every 10 minutes for 30 minutes. That goes into there 3 times. She's run a distance of 3 miles. On this side, she's going to make a 90-degree turn. And then she runs straight for 40 minutes. Let's go up to the top of the page here. At the same pace. So that's going to give me 40 minutes. She's going to run 4 miles. What's the distance between her current location and home? This is actually a special right triangle called a 3, 4, 5 right triangle. It's important to know this one with trigonometry, or with trigonometry, but with pre-calculus here. So we were told this was a right angle. We'll use the Pythagorean theorem just to prove to you that that side is 5. This is 3 squared plus 4 squared is equal to x squared. This is 9 plus 16 is equal to x squared. So we're going to take the square root. Both sides, it's a positive distance, so I don't need plus or minus here. That's the square root of 25 is going to be equal to x. X is going to have to be equal to 5. Some other special right triangles. I mentioned 3, 4, 5. There's also 5, 12, 13, 7, 24, 25, 8, 15, 17, and there's some others. Also, scalar multiples of these proportions will work. The third side that I've put there is always the hypotenuse. The other 2 sides that I've listed first are the legs of the right triangle. So you're going to also have some special relationships for a 30, 60, 90, 30 degrees, 60 degrees, 90 degrees right triangle. Those will be in a proportion of 1 to the square root of 3 to 2. And then your 45, 45, 90 right triangle will be in a proportion of 1 to 1 to the square root of 2. We'll talk about those more when we get to trigonometry, but I figure since special right triangles came up, we might as well mention them here. All right. the Reynolds number, which helps us identify whether or not a fluid flow is turbulent, is given by RE is equal to rho mu capital D over mu, I believe. No, that's rho U D over mu, excuse me. If rho U and D, all those things in the numerator, are held constant while mu increases, does the Reynolds number increase, decrease, or stay the same? So if the numerator stays the same and the denominator gets bigger, the fraction gets smaller. Just think about if it was a 1 up here. For right now, we're talking about 1/2, 1/3, 1/4, 1/5, and so on, where all the things up there stay the same. As the denominator gets bigger, the fractions are getting smaller. So you can just keep doing that. And that's something that you need to know. If you don't change the numerator and you make the denominator bigger, you're making the fraction smaller. If you make the denominator smaller, leaving the numerator alone, you're making the fraction bigger. All right. Consider a square base box. Got a box with a square base. So all the sides of the base are of length S, they're all the same, whose height is twice the length of the base of the side. So its height is twice the length of one of the base sides here, is going to be 2S. Have S, 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 2S, 2S. You get the idea. It's a box like that, right? If the length of the square base is 3 feet, so if S is equal to 3, find the volume of the box. Well, the volume is going to be S squared times 2S, length times width times height. So my volume is going to be 2S to the third, and they tell us that S is 3. 3 to the third is 27. 2 times 27 is 54, and this is in cubic feet. It told us don't forget the unit. In fact, they put an exclamation point there. They're really serious about that. Velocity of periodic waves, V, is given by the formula that V is equal to lambda, that's wavelength, times F is frequency. If the wavelength is held constant while the frequency is tripled, what happens to the velocity of the waves? So bigger well, I gave away the answer, but let's just say this is our V initial, our V final is going to be lambda, and I'm going to triple this. That's going to be change the order of multiplication, put some parentheses in there. So that's 3 times my initial, right? So when I multiply frequency by 3, I'm multiplying velocity by 3. Consider a square base box whose height is half the length of one of the sides of the base. So it's maybe like this, where this is S over 2, This is S and this is S, so my volume, nope, I want surface area this time. My surface area is going to be, so I'm going to have a top and bottom of the box. They're going to have an area of S squared because they're square. Then I'm going to have four sides to the box. So 4 times S squared over 2, because it's going to be side S times S over 2 is S squared over 2. And there's 1, 2, 3, 4 of those. So 2 is going to go into 4 2 times. It's also going to be 2S squared. So my surface area, I'm just going to call that capital S here. My surface area is equal to 2S squared plus another 2S squared. So that's my top and bottom. And that's my 4 sides is equal to 4S squared, where little s is the length of one of the sides. And it says that the surface area is 16 square feet. Okay, so that means that my side squared is 4 square feet. That means that my side has to be just 2 feet in length. So my volume then is going to be S times S times S over 2. It's going to be S cubed over 2. This is 2 feet cubed over 2. That's going to be 8 cubic feet over 2 is going to be 4 cubic feet for my volume. That was a little bit more complicated. Now we're on to number 25, 22 through 25. We're going to look at the work that is shown here and see if there are any mistakes in the work. So we're going to start off with 12 divided by 6 times 4 minus 3 minus 4 quantity squared. So 12 divided by 6 times 4 minus a negative 1 squared. We're going to take care of the exponent. Ooh, there's a mistake right there, is that we should have the subtraction left alone here. This should have been 12 divided by 6 times 4 minus 1. The subtraction should have been left alone when I did those exponents. A negative 1 times a negative 1 is a positive 1. So I'm subtracting a positive 1 is subtracting 1. Then I would go ahead and I would do my, and this is done wrong, that they did this multiplication before that division. Multiplication division happened at the same time, left to right. That's 2 times 4 minus 1 is 8 minus 1. That should be 7. So that should be the correct work. Should be 12 divided by 6 times 4 minus a negative 1 squared. Okay. See if we made any mistakes in this problem here. Negative 3 squared plus 6 divided by 2 plus a negative 4 squared. They're going to go ahead and they're going to take care of their exponents first. They say this is negative 9 plus 6 divided by 2 plus 16. That looks good so far. Now they're going to go ahead and take care of the division next. This 6 divided by 2. and they say that that's 3. That looks good so far. Now they're going to do all their addition and subtraction. Watch out, because they're doing it all kind of fast. This is -6 plus 16, that's 10. That looks good to me. Let's go ahead and let's look at number 24 now. 24 asks us 2 plus 3 minus 5 over 2 minus 2 times 6 plus 3. On the outside of that fraction, we have plus the square root of 64 plus 36. So they said that this is 2 plus a -2. They're doing those parentheses. And they left everything else alone. No reason to leave everything else alone. They did. Okay. Then they did these parentheses. They did some multiplication at the same time. It's really not great to do that, but that's okay. 2 minus 2 times 9. I wouldn't call that a mistake. Oh, I see their mistake. You better not do this. Okay, so they're going to say that this is 0 over 2 minus 18. That all's fine, but you better not say that this is the square root of 64 plus the square root of 36. That's wrong. This is the square root of 100. So this is going to be 0 plus 10. 0 divided by any non-zero number is going to be 0. So this is going to be 0 over -16 is 0. 0 plus 10 is going to give me 10. So there was a mistake right here that they tried to say that the square root of a plus b, they tried to say that that was equal to the square root of a plus the square root of b, and that's wrong. You can't do that. You can only split up multiplication and division of square roots. You can also split up when I have the nth power on them. It can be raised to the nth power on the outside, or I can do it to each in the fraction or each of the factors. All right. That was a common mistake. That's a good one. Number 25 asks us, I have to zoom out just a little bit here on this one. It says -3 plus 1 times 2 times a -3 minus, there's just lots of parentheses here, is what's going on. With 3 squared minus 3 times 1. So we close all the parentheses. There we go. There we go. Okay. First things first, they did -3 plus 1. It's 2 times a -3. And they did this was a denominator here of 3 plus 1 squared. All right, so they're rewriting their numerator, which is okay. Now they're going to take care of the exponent in the numerator. Now they're going to take care of these parentheses here. And these parentheses here. Negative times positive. Negative times negative is a positive, so that's fine. Negative times a negative is a positive. Positive times a positive is a positive. But we're subtracting a positive, so it's like that. Over. Oh, they made a sign error. There it is, right there. There's the mistake. So watch out right here, where it was a -2 times a -6 is a +12. So we're going to finish this up the right way. This is going to be 6 over 4 is going to be 3/2. Okay. And I think that that was our last problem for this section. Yes. So we'll come back next time and look at problems for 1.2, which will be an introduction to functions. Thank you.